Let's do some practice of simplifying radicals. So the rules for simplifying radicals are you can't have the square root on the denominator. So right away I could just simplify it by doing this. That's one of the rules. I can take the square roots of the top and the bottom. But one of the things you can't have is a radical in the bottom. So to resolve that, you multiply it by whatever will get rid of that radical on the top and bottom. If I multiply it by radical 5 times radical 5 is radical 25, which is just 5.
Yeah.
And now on the top, a lot of people, what they'll do is they'll multiply 5 and 18 together, but I wouldn't do that yet. In fact, what I would do is I would break up 18 into its product of primes. 18 is really 2 times 3 times 3, right? Times 5 is that 5 there. So those all go underneath there. And then I look at it and say, oh, what do these have in common? What perfect square factors do I have in here? And you can see right there, 3 times 3 is 9.
Yeah.
Well, there's 2 of them, and this is a square root. So what's the square root of? So let me break it up even one step further. So I could take that out. I could do it like that. I could break it up into square root of 9 and square root of 10. See how I took the 2 and the 5? And then the square root of 9 is just 3.
Yeah.
So that just equals 3 root 10 over 5.
Yeah, I get that.
All right, so that's the key. That's what we're trying to do. So let's do this one here. The first step here is to simplify this. Anytime you can simplify a fraction, do it. Those both have a 2 in common, right? If I take that, that's going to be 5, and that's going to become 12.
Yeah. So you're looking for a common between the numerator and denominator first before anything?
Well, the first thing you should always do is, simplify. Notice 18 and 5 don't have anything in common, so I didn't have to simplify it. But always simplify fractions. Whenever you can, you should simplify fractions. So now what I have is, I'm going to leave this 2 right here stays on the top, so I'm going to put that up there to not confuse you. I'm going to just rewrite it like this. Okay. A lot of times it's hard for people to see what's in the numerator and what's in the denominator, so I like to clearly label it. Right. And if there's nothing underneath it, you always assume it's a 1.
Okay.
So the 2 would be in the numerator. Now let's do that same thing we did before. We'll have to multiply the top and bottom by
square root of 5.
Square root of 5. Square root of 5. When I do that, let's do that same thing. Now, a lot of people would say, well, first simplify the 12. Well, I just wait. I wait. So this is going to be 5 on the bottom. This is going to be 2. And this is going to be 12 is 2 times 6.
Yeah.
6 is 2 times 3. So there was 12, and then there's the 5.
So,
and what comes out?
Square root of 4 is 2.
So those break jail, and I get a 2 that pops out of there, right?
So it'd be a 4
so a 2 comes out. Yep, and 2 times 2 is 4, right? So I got 4 on the outside.
4.
This 3 times 5 I can just multiply together because I'm simplifying it all over 5.
Okay. All right.
There's your answer. Let's do this last one. These can't simplify, so let's just rewrite it like this. Whoops. Multiply it by the square root of 7 on the top and bottom. Those cancel and it becomes 7 on the bottom. This 30 is 3 times 10. 10 is 2 times 5 times 7. Is there anything that can break jail from that? Any perfect square factors in there?
Not that I see.
No, because I don't have any doubles. These are all. That's why I always break it down to the primes, because you can see everything if you break it down to this product of primes. So now you can just combine them back together and do it in an easy way. 7 times 3 is 21. 2 times 5 is 10. 10 times 21 is 210.
So for 30, how did you know to do? What is it? 3 times 10?
3 times 2 times 5. It doesn't matter how you do it.
For the 30, and that's 6 times 5.
So how did I originally know to do 3 times 10? It doesn't matter.
So I could have done 6 times 5.
What would 6 times 5 give you?
30.
6 isn't done yet. What's 6?
That's
2 times 3.
Oh.
See how it's always going to end up with the same thing. That's why the product of primes is what to use. It'll always get you down to the same thing if you do product of primes.